Welcome to solverfy.
So we're in chapter 23, problem 15 here. And it says an insulated spherical conductor of radius r1 carries a charge big Q, and a second conducting sphere of radius r2 is initially uncharged and then connected to the first by a long wire. Okay, so part A says, after the connection, what can you say about the electric potential of each sphere? So after the connection, we can immediately say that they are at the same potential. Why can we say this? Well, if they were at different potentials, then there would be a flow of charge in the wire because charge always flows from higher to lower potentials. And this happens until the potentials are equalized. So after it's connected, it'll flow a little bit, and then once the potentials are equalized, then the charges will stop flowing and they'll be stabilized at the same potential. Part B, how much charge is transferred to the second sphere? And it says assume that the connected spheres are far apart compared to their radii. Okay, so we assume, and it says why make this assumption? Well, first we assume that they're far apart so that the charge of the sphere doesn't have any influence on the other charge of the sphere, because these are conductors, so being close to a charged sphere is going to induce a charge onto the conductor. But we're going to assume that they're very far away so that they don't. Okay. So initially, all the charge is on sphere 1, right? So initially, Q1 is 0, or Q1 is Q, and Q2 is 0. And we always have the condition that Q1 plus Q2 equals Q. Okay. So the second case then is that V1 equals V2. So first, let's write out what V1 is initially, and this is Q over 4 pi epsilon naught R1. And V2 can then be written as Q minus Q1. Oh, let's write this as Q1, right? So Q minus Q1 is 4 pi epsilon naught R2. So if we set these equal to each other, we just have to figure out how much charge was transferred. So set this equal to Q1 over 4 pi epsilon naught R1. 4 pi epsilon naughts cancel out. Then we solve for Q minus Q1, and that equals Q1 R2 over R1. So this is good, but it tells us in relation to Q1, right? But we don't want that in our final answer. So let's figure out what Q1 equals. We can solve this equation for Q1 first, and we see that Q1 is equal to Q times R1 over R1 plus R2. So let's plug that into our equation, and then we know that Q minus Q1 is given by Q times R2 over R1 plus R2. And that's how much charge was transferred. Awesome.